Hello, people! How are you doing? Today, we will be discussing a new and exciting lesson. We will be learning about unpaired sample status. Are you ready? Before starting, I have a few reminders. First, listen carefully. If you have not understood a certain part, you can always replay this video lesson. Second, avoid distractions. Close other applications when watching this video using your phone. Third, questions are welcome. You may reach me through FB Messenger or WhatsApp. Then, keep social distancing and wear masks if you are watching with someone aside from your immediate family. This is applicable to those learners who do not have personal cell phones and must share with their nearby classmates. Copy of this video lesson is also available online in my YouTube channel for those learners whose phone have limited storage capacity. So don't forget to subscribe to my YouTube channel. And lastly, capslets having the same content as this video lesson is also provided for those students who lack gadgets and are in a far-flung area. To begin with our lesson, let us determine our objectives. First, describe an unpaired sample status. Second, solve mathematical problems involving an unpaired sample status. And lastly, follow step-by-step procedure in solving mathematical problems involving unpaired sample status. In our previous lesson, we have learned about one sample t-test. For the sake of recall, I have discussed to you that one sample t-test is a type of student's t-test that we use to compare the mean of sample data to a known value. For example, let us assume that as a student researcher, you decided to investigate the effectiveness of brown algae as chicken feeds of poultry chickens. You then decided to compare the mean weight of your experimental chickens to the standard mean weight of poultry chickens as provided by the National Meat Inspection Service, or NMIS. In this case, you do not need to have a control group because you are comparing the mean weight of your experimental setup to a standard weight provided by an agency. But what if there is no known value? What if the NMIS could not provide you with a standard weight? In this case, you may need to have both a control and experimental group to help you find out if brown algae pellets are an effective feed of broiler chicken as the commercially available chicken feeds. In this case, you may no longer use one sample t-test as a statistical tool in comparing means. Instead, you will have to use unpaired samples t-test. So what is unpaired samples t-test? How does this t-test determine the significant difference between the means of the control and experimental groups? Let us use the above-mentioned situation to better understand what unpaired samples t-test is. Let us assume that you work in a poultry farm. Because you want to cut costs and to utilize locally available materials, you deemed that there is a need to conduct an investigation to look for alternative chicken feeds for your broilers. Since you live in a coastal community, you have also observed that there is an abundance of brown algae along the shorelines that the Sama Badjao, an indigenous group, used to sell along the streets. Thus, you have decided to determine if brown algae could be an additive in your chicken feeds and if it is as effective as the usual chicken feeds to give to your broilers in terms of the weights of the chicken at the end of the experimentation. Eventually, you will also be able to help the Samabajao community in their livelihood. Further, you went to NMIS to determine what the standard weight of broiler chicken is for data analysis, but the NMIS could not provide you with such data. You then decided to use unpaired samples t-test in this case. In your investigation, you have prepared 20 chicks you have randomly selected from your farm and divided them into two groups, 10 for the control group and 10 for the experimental group. You gave the experimental group chicken feeds you made from brown algae, while you gave the usual chicken feeds to the control group. At the end of 6 weeks, you measured the weights of the chickens and gathered the following data. As you may be able to see in our PowerPoint presentation, Table 1 shows you the weights of the chickens fed with brown algae on the first column and the chickens fed with the usual chicken feeds on the second column. These were measured after the experimentation, which was after 6 weeks. Given the data above, is there a significant difference between the mean weights of the two groups of chicken? Can the brown algae chicken feeds be an alternative chicken feed to chicken broilers? To answer the questions given, you will have to run an unpaired samples t-test. So what is an unpaired samples t-test? Unpaired samples t-test is a two-sample t-test used when you want to compare two independent groups to see if their means is different. It is also called independent samples t-test. When do we use unpaired samples t-test? Unpaired samples t-test is used when we do not know the population mean or standard deviation and if we have two independent separate samples. So first thing, we do not have a standard deviation or a population mean, which could be provided by the NMIS, but we've found out from our problem that the NMIS could not provide us with such data. And then we have two independent separate samples, the experimental group and the control group. What are the assumptions for the unpaired samples t-test? First is the assumption of independence. You need two independent categorical groups that represent your independent variable. In your case, it will be the control group and the experimental group of chickens. Another assumption would be the assumption of normality, where the dependent variable should be approximately normally distributed. The dependent variable should also be measured on a continuous scale. In the situation you are given, the weight of the chickens would be the dependent variable. And another assumption is the assumption of homogeneity of variance, which is the variances of the dependent variables should be equal. So those are the three assumptions of unpaired samples t-test. Now, let us run an unpaired samples t-test. So the first step in writing or in running an unpaired samples t-test is to first write your null hypothesis. In our case, our null hypothesis would be there is no significant difference between the mean weight of the chickens fed with brown algae and the chickens fed with the usual chicken feeds. So in formula, our null hypothesis would be x sub A is equals to x sub B, or the mean of A is equals to the mean of B. Mean of A is equals to the mean weight of chickens fed with brown algae feeds, and the mean of B represents the mean weight of chickens fed with usual chicken feeds. Step 2 is to write your alternative hypothesis. And in our case, our alternative hypothesis is there is a significant difference between the mean weight of the chickens fed with brown algae and the chickens fed with the usual chicken feeds. Or in formula, we write it this way. The mean weight of A is not equal to the mean weight of B. Step 3, we will be providing the decision rule for rejecting the null hypothesis, including the critical value for the appropriate statistics. So our decision rule would be to reject the null hypothesis if the computed t-value is greater than 2.101. Otherwise, fail to reject HO. In formula, we write it this way. Reject the null hypothesis if the critical t-value is greater than 2.101 or 2.10. Now, how did we get 2.101 or the critical t-value? To get the critical t-value, you must get the degree of freedom by subtracting 1 from the total number of samples in each group. So our number of samples for each group is 10. So we subtract 1 from each group. That is 10 minus 1 is equals 9 for the group A, or the group of chickens fed with brown algae, and then 10 minus 1 is equals 9 for the group B, or the control group, the chickens fed with the usual chicken feed. And then we add 9 plus 9, and that would give us 18. Then, using the t-table, we'll look for the critical t-value using 0.05 alpha level for two-tailed test, since our hypothesis is two-directional. Let us look at our t-table to determine what our critical t-value is. So our critical t-value based on our t-table is, again, our degree of freedom is 18. So let's look at the column for the degree of freedom, which is here. So our degree of freedom is 18, and 18 is here. And then our significance level, or our alpha level, is 0.05 under two-tailed test. So two-tailed test, and then we look for 0.05, which is 5% equivalent. Then we look for the number that, or we search for the number at which the significance level and the degree of freedom intersects. So 18, and there we have it. Thus, our critical t-value is 2.101 or 2.10. Step 4 is to sum the weights of the two groups. So for the first group, we simply add all the weights of all the chickens fed with the brown algae feeds, the total of which is 16.97 kilograms. And then next we add all the weights of the chickens fed with the usual chicken feeds, the total of which is 16.85. So that is the sum of the weights of the two groups. The next step is to square the sums from step 4. So that is, the square of 16.97 is equals to 288.05. So that is the square of the sum of the chickens, of the weights of the chickens fed with brown algae feeds. And then for group B, the chickens fed with the usual chicken feeds, the square of its sum is 283.92. You may use scientific calculator to be able to do this mathematical computation. Step 6 in running an unpaired samples t-test is to calculate for the means for the two groups. So we have for group 1, or for group A rather, we simply add all of the weights of the chickens we've found in table 1 and then divide it by 10. So the answer would be 1.697. That is the mean weight of the chickens fed with brown algae feeds. And our control group, or chicken B, the mean weight of this chickens is 1.685. Step 7 is to square the individual scores and then add them up. So we simply square all of the individual weights of the chickens, square them, and add all of these squares until you reach the final answer. For group A is 28.93. And the square of the individual scores of group B, or the chickens fed with the usual chicken feed, is 28.53. Step 8 is to insert your numbers into the following formula and solve. So here's our formula in computing for the t value. It's quite a lengthy formula. The description is here. We are also provided with at which step they could be found, which we did a while ago. And then so we insert the numbers. That is 1.697 minus 1.685, and then 228.93 minus 288.05 divided by 10 plus 28.53 minus 283.92 divided by 10. And then under, we have 10 plus 10 minus 2, and then 1 over 10 plus 1 over 10. I'll also be showing to you how to input these numbers using scientific calculator, as this is much more convenient than doing them individually. So while looking at how I input the numbers, you would like to inform the class that you can download this application from Google Play. Just make sure that the app that you are going to download is Google verified. So, and also, You can just input scientific calculator on the search bar, and then all the apps are there to choose from. Choose which you think is suitable for you, depending upon the capacity of your phone storage and other things. Also, check on the review portion before downloading, because the reviews of other users are also important for you to assess if those apps are really helpful or they're just filled with bugs and advertisements. So that is how you input the numbers using scientific calculator. Very convenient. All you have to do is to make sure that you're putting the numbers correctly and putting the parentheses correctly also, as if the parenthesis is wrong, then the scientific calculator would not be able to get the answer right. So there we have it. The final answer is 0.22. So again, our computed t-value is 0.22. But that doesn't end there. Step 9 is to find the degrees of freedom. So again, degrees of freedom is subtracting 1 from each of the number of samples. So the degree of freedom that we have is 18. And then step 10, look up your degree of freedom in step 9 in the t-table using 5% alpha level. So our degree of freedom for 18 at an alpha level of 0.05 is 2.10. If you could remember, we've done this on, I guess, step 3 also. So this is just for emphasis purposes. Step 11 is to compare your calculated value, which is found on step 8, to your t-value or table value, which is found on step 10. So the calculated value of 0.22 is less than the cutoff of 2.10 from the table. Thus, we go to step 12, which is decision. Since the computed t-value is less than 2.101, then we fail to reject HO. So in other words, for our conclusion, there is no difference in the mean weights of the two groups of chickens. Therefore, the brown algae feeds are just as effective as the usual chicken feeds in increasing the weights of the chicken broilers. Now I want you to remember the following. If the computed t-value is more extreme than the critical t-value, we should reject the null hypothesis. But if the computed t-value is less extreme than the critical value, do not reject the null hypothesis. So in our experimentation, our computed t-value is less extreme, is less than the critical value. That is, 0.22 is less than 2.101. That means that we do not reject the null hypothesis. So let me just emphasize, 0.22 is less than 2.101. 0.22 again is our computed t-value, and 2.10 is our critical value. So since 0.22 is less than 2.10, we should not reject the null hypothesis, which is there is no significant difference in the mean weights of the two groups of chickens. So in other words, these two groups of chickens, although they have a slightly different mean weight, that means that their mean weight is not significantly different. And so that means that the brown algae is just as effective as the usual chicken feeds in terms of the difference in the weight of the two groups of chickens. Now let us assume that we have 2.21 instead of 0.22, and we have still 2.10 as our critical value, t value. 2.21 is now greater than 2.10. Okay, so our computed t value is greater than our critical value. That means that we should reject the null hypothesis. Okay, that means that there is a significant difference in the mean weights of the two groups of chickens. Assuming that this is our computed t-value, 2.21, then that means that there is a difference, a significant difference between the mean weights of the two groups of chickens. So that could further mean that our brown algae is much more efficient, much more better, that's a redundancy, is way better or is better than our usual chicken feeds in terms of adding weight to our broilers. So let's take a look on other practical applications of unpaired samples t-test. So for example, we want to compare t-test scores we want to compare test scores of male and female students. If we want to determine if male students are scores better than the female students or if it's the other way around. When we want to find out if birth rate is higher in Asian countries in comparison to European countries. So notice our dependent variable there would be birth rate, and our independent variables would be the countries, Asian countries versus European countries. Another practical application for unpaired samples t-test is when we want to determine if there is a significant difference in Taylor Swift's sales of her Big Machine version or Taylor Swift version of albums. So Swifties out there, I know you're very much familiar with this. And then when we want to compare scoring average of the Golden State Warriors for basketball fanatics, when Stephen Curry is playing or not, does the Golden State Warriors have higher score when Steph is out of the game or when he's inside of the game? And then when we want to find out if the 60:40 cement to sand ratio can hold more weight than 70:30 cement to sand formulation. So those are practical applications of paired sample t-test. So we could also use it in education, in school, in comparing world population, for example, in the music industry, in sports, and in engineering, in architecture, and many other fields. These are the generalizations that we've come up with from our lesson today. So, first generalization, unpaired samples t-test is also known as independent samples t-test. Second, unpaired samples t-test is used when you want to compare two independent groups to see if their means is different. Third, it has three assumptions: assumption of independence, assumption of normality, and assumption of homogeneity of variance. Fourth, assumption of independence means that there are two independent categorical groups that represent the independent variable. Assumption of normality means that the dependent variable should be approximately normally distributed and should also be measured on a continuous scale. Assumption of homogeneity of variance that the variances of the dependent variable should be equal. And if the computed t-value is more extreme than the critical t-value, we should reject the null hypothesis. And lastly, if the computed t-value is less extreme than the critical value, we do not reject the null hypothesis. For our evaluation, you may take a screenshot of our problem here. So our problem is an anthropologist is conducting a study on the sustainability of the Yakan dialect in Basilan province. He thinks that Yakan people under the age of 40 have vocabularies that are different than those of people over 60 years of age. The anthropologist administers a vocabulary test to a group of 10 younger respondents and to a group of 10 older respondents. Higher scores reflect better performance. The scores of the younger respondents are 17, 19, 22, 21, 23, 17, 16, 23, 24, and 19. Meanwhile, the scores of the older respondents are 24, 31, 24, 37, 38, 39, 32, 22, 23, and 35. Using unpaired samples t-test, determine if there is a significant difference in the scores of the two groups. So for the evaluation, you may write your solution in a one whole sheet of paper and submit it to your advisor on the next retrieval date, which is tentatively on April 27, 2022. You may also opt to submit your solution online via Gmail for your respective sections. So again, for Platinum, that is muzarinplatinum@gmail.com, and Muzarin Titanium for the Titanium section at gmail.com. Make sure you submit on the correct Gmail for easy checking and to avoid wasting of time. Failure to submit on the proper Gmail is tantamount to not submitting it at all. So be careful in typing. For the extend part, go back to slide number 38 titled Other Practical Applications of Unpaired Samples t-Test. Determine what are the dependent and independent variables for each situation. I have already mentioned the answers for practical application number 2 if you were listening. Submit your answers together with your solution in the evaluation. And that ends our lesson for this session. I hope you have learned a lot from unpaired samples t-test, and if there are any clarifications, questions you have in mind, do not hesitate to contact me or to reach out to me through the different social media platforms that I have posted. And yeah, thank you for listening and have a nice day.